Welcome again. In this lecture, we'll see how to use some arithmetic operations on images. Let's start by creating a new Python file. I will call it arithmetic operations.py. First, I will import CV2 and numpy. So first, let me show you how the operations are done using numpy integers. For example, if I create a variable called x and p.uint8, this variable will take 250 for example. So this will be just a scalar or an array with just one element array. 250. We can also print it, so that's print x, and I will come here Python arithmetic operations.py. So we can see 250. If I create another numpy.uint8 and I will give it 10 for example, so this is just for also an array with one element 10. So what if I do some operation, for example addition? So if I do normal addition, it will be and I print it, so print x plus y. So we see it here, so it is 4. Why it is 4? Because we have here 250 plus 10. This will be equals to 260, but the numpy uint8 is just in the scale of it is in the scale of 0 to 256. For that, any number, so it will take the rest of this number on 256, which is 4. So the result will be 4. This is the normal addition, but with OpenCV we can the addition is different, or the process is different. So if I say it's OpenCV addition and then print it like that, cv2.add is like that, add, and if I add these two variables, so we can see here the result. So it is 255. With OpenCV we will have this 250 plus 10, it is equals to 260, but in OpenCV the maximum is in the scale of 0 to 255. So it will, if it is bigger than 255, it will be set to 255. So this is how OpenCV do the addition. For example, we can see it now with images. So if I comment this and if I load some images, or I read some images, so let's me read, for example, image 1. So cv2.imread, I will give it one image from here. For example, I will give it these two images, the apple image. Be sure that the dimension of these two images should be the same. So the apple here and the other image here, their dimensions are the same. This is important when you are doing some operation or arithmetic operation in OpenCV. So I will load this data, apple for example, and image2 is equals to cv2 dot imread data, and I will call this image. So if I show these two images, cv2.imShow image1, and cv2.imShow image2, then cv2.waitKey 0. If I run the code, it will be shown here. Now let's do some arithmetic operation on these images. So if I do the normal addition, it will be, for example, result 1, or normal addition. I will call the image normal addition, and it will be just image 1 plus image 2, or image 2 plus image. There is no difference. And the OpenCV addition, and I will call it OpenCV addition, and in this case it will be cv2.add, and give it the two images, image 1 and image 2. Let me show them here, so I don't need the original images, or I can show them together. cv2.imShow, give it normal addition. I will give it normal addition, and cv2.imShow OpenCV addition. I will give it the image here. Let me show them. So here are the original images. So here you can see the difference between these two images. We have here the OpenCV addition. You can see its effects here, and the normal addition of these two images. Also you can see it here. There is a big difference between the two methods. Usually the OpenCV addition is better and is used more. But sometimes we don't need to make this kind of addition because we don't want to change the whole image. Sometimes you want to add some blending or transparency on the images. OpenCV has the function to do that, so let's see it. For example, to blend two images, we can use cv2.add weighted here. So this image takes the first image and the alpha, which is the weight of the first image, and the second image also, and its weight, and another parameter which is gamma. We can give it as 0. So if I give it the first image and give its weight as, for example, 1.7, and give the second image and give its weight as 0.3, the sum of these two weights must be equals to 1. So here we have 0.7 plus 0.3, which is equals to 1, and we can give gamma as 0. So we can use here weighted image, and we can show it here as cv2.imShow weighted image. Let me call it here, so we can see it like that. These are the original images, these are the addition images, and these are the weighted images. We can change the weights of each image to make it more visible, or to hide the other image. So we can play on this scalars here. For example, if I give it 0.4 here and 0.6 here, the second image will be more visible than the first image. Let me show it here. So you can see now that the second image is more visible now. Another type of arithmetic operations is the bitwise operations. So if I appear bitwise operations, this includes, for example, not, or, XOR, and so on. So let me show how they are working. Let me comment these ones and also comment these ones here, we don't need them. So if I do here not operation, for example, I will call the resulted image not operation and call it cv2.bitwise not, for example. This I will give it the first and second image and second image, and for example and operation, and it is cv2.bitwise and image 1 and image 2, and or operation, and I will give it bitwise or between image 1 and image 2, and XOR operation, cv2.bitwise XOR image 1 and image 2. Let me show them. cv2.im show. So the not image, not operation, and cv2.im show the and image, and I will do it here and operation, and cv2.im show or operation, and give you the image here or image or operation, and cv2.im show XOR image and give the XOR operation. Let's run the code here and see these images. So these are the results. XOR image, it is just a white image, the OR, the AND is a black image, and the NOT image. So here it takes all the like 255 in the image, so it's resulted in a white image. The same here in XOR, while in AND image it takes just the just to the zeros. So here just the zeros, while in NOT image the operation is different and we can see here a result. This will be clear when we do a project in these operations in the next lecture, and how they are useful and how we can use them, to do some specific applications. So see you in the next lecture and in the project that we will do.